EET 114, Chapter 19, Example number 49, which is maximum power transfer. Find the load impedance E sub L for the network for maximum power to the load, and find the maximum power to the load. So here's E sub L, and then here's the network that we're talking about. So the first thing we're going to do is find the Norton equivalent, because we have a current source. Alright, so what we do is we open circuit the current source, and then we have Z1, Z2. They're in parallel, as you can see, across these two terminals. So Z1, they abbreviated it to adding these together in series, so this would be 3 plus J4. And then Z2 is just 2 ohms angle 0. So you find Zn, which is also equal to Zth. Z1 in parallel with Z2. You guys all know how to figure that out. It's this times this all over this plus this. So when you do the math here, you get 1.56 angle 14.47. That's equal to Z Thevenin. And then they convert it back to rectangular. Now, here's the trick. You have to use the conjugate, which is just taking the J term and then inverting it, making it the negative. If this had been positive, or it is positive, Z sub L ends up being negative. If this was negative, this would have been positive. It's just the opposite. Okay? So that is the impedance. Alright? It says find the load impedance for the maximum power to the load, Z sub L. Now you need to find the maximum power to the load. So you put your current source back in, and then you find E Thevenin across these two terminals, which is going to be, it's just a current divider again. So, or I'm sorry, it's going to be, you take Z1 in parallel with Z2, and then you take the current through them, which is going to be I, the load current. So you combine these two impedances, and then you find the current going through it, which is I, and then multiply them together, and you get E Thevenin. Alright? So this is how they did it. Z1 in parallel with Z2. Again, you already found that up here. It's equal to this. And then you just multiply it times I, which was given. And you get this polar form of E Thevenin. And then to find the power, you use the formula that you guys were given. E Thevenin squared divided by 4 times R Thevenin. Now, what's R Thevenin? Well, that's why they broke up Z Thevenin to do an R component and the next component. The R component is 1.51 right here. So you take E Thevenin squared, which is the magnitude, we're just looking for the power now. So you don't look at the phase angle. The magnitude of the voltage squared times 4 times the resistive component of the Thevenin impedance, which would be this, 1.51. And then you get 1.61 watts.